VR applications generate large amounts of data that need to be stored and managed efficiently. Cloud computing can provide secure and scalable storage solutions that can be easily accessed and managed from anywhere in the world. This can also improve the portability of VR applications, enabling users to access air applications and data from any device. Finally, cloud computing can enhance the security and privacy aspects of VR applications. Security is critical in VR applications, as they often involve sensitive data, such as personal information or medical records. Cloud computing can provide robust security solutions, such as encryption, authentication, and access controls, to protect sensitive data and prevent unauthorized access. As technology continues to evolve, the potential applications for cloud computing in VR are likely to expand even further. One area of growth could be in the use of VR for remote work and telepresence. Additionally, the combination of cloud computing and VR could enable new applications in fields such as architecture, engineering, and construction, AEC. VR can enable architects and engineers to visualize and test designs in a 3D virtual environment, improving design quality and reducing costs. By utilizing cloud computing, these applications can offload the high computational demands required for such tasks, providing faster iterations and more accurate simulations. Another promising application could be in the field of gaming and entertainment. The combination of cloud computing and VR can enable cloud gaming, where VR games can be streamed from the cloud to an Wi-compatible device. This could provide gamers with access to high-end VR experiences without the need for expensive hardware. Cloud gaming can also democratize gaming, providing more affordable options for players from developing countries or those with limited resources. As with any emerging technology, there are also potential challenges and risks associated with cloud computing and VR. One concern is the potential for data privacy and security breaches. VR applications often require users to provide personal information, and cloud computing involves large amounts of data storage and processing. Organizations will need to implement robust security measures to ensure the protection of users' data and prevent unauthorized access. Another concern is around accessibility and affordability. While cloud computing can improve the accessibility of VR applications, it is still a relatively new technology with high costs associated with its storage and processing. This could limit access to VR experiences for those without the necessary resources. However, to fully realize the potential of cloud computing and VR, it is essential to address the challenges and concerns associated with the integration of these two technologies. For instance, as mentioned earlier, one challenge is the high computing power required to render realistic and immersive environments. VR applications demand high-fidelity graphics and animations and require significant processing and storage capabilities that can be challenging for most devices. Although utilizing cloud computing can offload processing and storage demands, developers must ensure that the cloud infrastructure can handle the volume of data generated by the VR application. It is also important to ensure that the cloud infrastructure is always available to avoid service interruptions that could lead to a poor user experience. Another challenge is the potential for lag or latency in VR applications. VR applications require a high refresh rate to achieve realistic and immersive experiences. Any delay could diminish the user's level of immersion, leading to motion sickness or disorientation. Cloud computing can optimize latency, however, developers need to ensure that the network infrastructure used for transferring data between devices and the cloud network is fast and stable. Another challenge is developing VR applications that work seamlessly across a range of devices. Different VR devices have varying processing capabilities, rendering pipelines, and input methods. There. 4. Developers need to design VR applications that can adjust their settings to accommodate the capabilities of different devices. This can be challenging, especially if the VR application has complex graphics and animations. Lastly, the cost of VR hardware could be a potential barrier to the widespread adoption of VR applications. Although utilizing cloud computing can make VR applications more accessible, VR headsets and devices can still be expensive for most individuals and organizations. However, many companies are now exploring subscription-based services or pay-per-use models to make VR applications more affordable.